Hello everyone, today we're going to take a look at the Trimble Realworks Floor Flatness Inspection Tool. So we'll jump straight to Realworks and show you how it works. So here in Realworks you can see we have carried out a number of scans within a mechanical boiler room. So the first thing we want to carry out is to isolate the floor from the rest of the actual scan data. So we kind of want to remove all this noise and all the objects that we're actually not going to analyze. So for us to do that we're going to make sure we're in our production tab. We're going to go to inspection. You can see here that the floor flatness inspection tool is actually grayed out, so what we need to do is click on the actual point cloud itself, and now you can see how it's highlighted. We're going to launch the floor flatness inspection tool. Once it pops up, then we can start to clean up our point cloud for the actual analysis. So we have a couple of tools here to kind of help clean it up. So we can come to the first one here for sampling. If we click on the sampling tool, it's going to give us a number of different ways we can actually clean up the point cloud. So we have here a floor extraction for indoors. So we're going to select that. And then we're going to hit show outliners in red, so anything that's not part of the floor will actually turn red. And then we've got quite a large point cloud here, so actually what we're going to do before we do that is actually go to our spatial sampling tool, because rather than going through 385 million points, we're going to make it a little bit quicker on the process side of things. So if we go to the spatial sampling tool here, we can do a spatial sample of so what density do we want the distance between our points here. So you can see here we've quite a high density of points, so I'm going to probably pump it back to probably 1.25 or 1.5 of an inch. If I hit preview, it's going to tell me how many points I have within my point cloud. So it's a great way to sample back your point cloud. So you can see here it's computing down here on the bottom left hand of the screen. So now we're just working with 24 million points, what is what it looks like, and then you'll see the difference in the density of the points once it's actually completed. So once it's completed, you can actually see now that our spatial sampling is bigger between all the points. So you can see we went from 24 million points down to 7, so it's a lot easier to manage that amount of points. So once we're happy with that, we can just hit apply. So when our floor analysis, when we're doing our floor analysis, it'll be a lot quicker to define or get a result on our area. So once we have that, now we still want to clean up the point cloud to a certain degree. So we're going to go to, rather than spatial sampling this time, now we're actually going to switch it to the ground extraction, our floor extraction. And then we're going to show our outliners in red, and then once you're ready to go, hit extract. And then again, you'll see on the bottom left hand corner, it'll start computing what is the actual physical floor in our point cloud. So once it's complete, you can see the actual initial results. So it looks like it did a pretty good job on what we want for our floor. So you can see how it's after actually removing all the noise and all the other objects from our point cloud. So if you did have something that was a false return, you could obviously keep, you can select the keep floor option, and then you can digitize around an area and say no, that this is part of the floor. Or vice versa, you could actually try and remove something as well too. If something was digitized that was actually part of the floor, you can remove it and put it back into the ground. But that we don't need to do that in this situation here. We got a pretty good result from our point cloud. So what we can do next is hit apply. So now you can see we're just working with the actual ground. All other noise has been removed, and we can just jump to these different viewpoints of our point cloud again. So where you had these the chairs and the table here, all that has been removed. So really great way to clean up your point cloud. So once that is done now, I normally switch to a top-down view, and then I just go to my perspective just to give me a greater overview. And we're going to define an area that we want to, calculate the flatness of the floor. So we can just draw a square around our area of interest, and then the next thing then you're going to do is define the grid spacing. So for this example here, I have it 2 inches. So the way it'll work is it's going to break up the point cloud 2 by 2 inches, and it's going to run the analysis on that. The next thing I could do is I can pick an elevation. So for example, if I know a benchmark reference point, I can always continuously select that point. We say, for example, if we had poured a concrete floor and we left the concrete cure, I can pick, I can do my initial scan, pick, we say, the top left hand corner here of the point cloud, run my analysis. Then I could come back the following, we say, in a couple of weeks when the concrete is cured, pick the same reference point, and again it's going to compare those 2 points. So if there's any difference on the concrete over that time period, you can compare and contrast both results. But for here, I'm going to pick where we have a floor drain here as my reference elevation, just to kind of give you a good context of kind of what we're looking at. So that's my reference elevation. Once I'm happy with everything, so if we do have a blank area where we don't have a point cloud, or maybe there's something blocking the point cloud, we can fill in the holes, so it'll interpolate what that distance is. You can also have your out of tolerance, so it'll show you what's out of tolerance based off of a color heat map. So once we're happy, we can do a preview. So now here's our preview. So it's a little bit hard to see kind of what's going on here. So we can, turn off the cloud, and then we can turn off the grid, so we can really start to see our floor analysis. So you can see here where we referenced our point cloud off of the floor drain. Blue is showing you that it's below reference elevation, so it's where there's a fall in the ground, which is what we're expecting because we have a floor drain. And you can see here then that we have a really bright dark red where we have our concrete pads to show that. And also here you can actually see there's a slight little rise, and where that information is actually coming from is from we have some cardboard actually lying on the ground, and it's actually able to detect that minute difference in the actual height of the actual concrete. So if we're happy with everything, we can actually create our floor flatness, and we just want to maybe just turn on the point cloud again, and then the display grid, and then we're just going to hit create. So once that is done, then you can close it down, and now you can see here it's after creating our floor flatness floor. We can go back one, and then you just want to turn off the actual main point cloud of the project, so we can actually inspect our floor flatness. So we go back here and we can turn on our results. So here you have our floor flatness. So you can see here with the grid, it actually shows you the outline of where the concrete pad is, and so on. So to kind of get a bigger, deeper dive into this, we can actually select our floor flatness results, and on here then you'll have the selected here under the inspection, and then you'll have an inspection map analyzer tool will populate up, and then this is going to split your screen into a couple of different sections. So we've got our our map analyzer viewer, we've got a cross section of the point cloud, so maybe you just want to make sure that you're facing the right way. So at the moment it's just upside down, so you can tell this by where the Z is facing, so I just want to maybe rotate that around the other way. And then the bottom right hand corner here is actually showing you an exaggeration between the actual point cloud itself, because some of we say the distances can be pretty small, so this is just showing you kind of a minute distance of that. So we can actually then pull the slider across to see a nice profile of our ground. So if I just slide it down here to where our floor drain is, and maybe just zoom in, I can actually see here where this floor drain is relative to my profile map. And if I want to as well too, I can get some extra distances on it as well too. I can pull with a distance on the vertical, just click anywhere on it, and then it's going to give me that. So it's about an inch deep. So you can get a really good kind of idea of what you're kind of working with, and you can even do a distance across as well too. So it's 8.6 inches wide. And again, just to kind of show you the exaggeration, you can see down here on this map, this is an exaggerated version of that floor drain. And you can also change it to a vertical inspection as well too. So if we just change it here, we can zoom out and do a little bit more analysis, looking at a different aspect of the point cloud. Again, you can see here there's actually another floor drain here, and we can actually see that floor drain again in the actual report. So there's a lot of great ways you can actually kind of easily distinguish what's actually happening to the concrete floor. Again, here's a quick slider bar in the difference between your low points and high points. We say 0 being the grey area. We know there's about maybe 4 or 5 inch height of the concrete pad there. A couple of other things you can do: you can create multiple slices for reports and whatnot, and you can even physically grab slides here as well too. You can do a nice little report and put everything together and copy and paste it into a Word document if you wanted to. So that's kind of a great way to kind of do some floor flatness analysis. If we just kind of go back to the point cloud, just to kind of show you where that cardboard was, just kind of show you the accuracy kind of coming from it. I'm just going to switch back to my point cloud quickly there, and if I go into merge, it's going to show me all my points, and then it's just back here. So if I double click on the point cloud, and then maybe let me turn off some of that, let's kind of go down to floor flatness analysis. So you can actually see this cardboard here lying on the ground that was picked up as well too. So again, we can clean up the point cloud as well too. The idea is that you'd actually get out before subcontractors start to say lay down material on the floor. Like if you can get out and take advantage of the ground before they start to say block it with other types of material, it just helps you on the cleaning side and saves time on that end. And finally, again, I suppose just to show you kind of some of the emphasis, you can see here we have the blue around again around the other floor drain, and you can see it around here as well too, and the red on the concrete pads, just to show you kind of more of a visual inspection on the actual floor concrete. So that's Trimble's Realworks floor inspection tool. Thank you very much.